Hey everybody, we're back and we're starting chapter 4. We're talking about trigonometric functions. Hopefully this is not the first time you've seen this. I'm hoping that you saw an introduction to this last year in your Algebra 2 class. But let's go ahead and get started. So today we're going to learn how to describe an angle and to convert it between radians and degrees. So hopefully those are not completely foreign words to you, but if they are, that's okay. We're going to talk about it. So first thing first, important vocabulary. So we need to know what we're talking about here. So trigonometry is a Greek word for the measurement of angles. Okay. The central angle of a circle is an angle whose vertex is the center of the circle. So I use this notation. Instead of writing the word out angle, I just kind of give it this. An angle, okay, what I call this angle, whose vertex is the center of a circle. So if this is a circle, here's the center, and a central angle would look like this. Okay, that's what we're talking about, central angle. Complementary angles are two positive angles whose sum is 90 degrees, or we say pi over 2 radians. And if you're not sure what I'm talking about, we're gonna come back to that. But just remember, just like you learned in geometry, complementary means adding up to 90. One of the ways I remember that is CO is like corner, and we know that's 90 degrees. Okay, supplementary angles. Supplementary means two positive angles whose sum is 180 degrees, or we say equal to pi radians, which is another way to measure an angle, which we will talk about in just a moment. And then last but not least, a degree, which we know what it is, but we probably haven't thought very much about defining it. So the unit of measure and it's denoted by the symbol remember that kind of raised up floaty little circle, by the symbol of what we call degree, where 1 degree is 1/360th of a complete rotation of the vertex of an angle, aka a circle, right? If I've got an angle here and it's going around it, that's a complete rotation. And we know 1 degree is one little sliver of it, 1/360th of that. Okay. Keep in mind also supplementary angles add up to 180 degrees, which is a straight line. So if here's the center and here's the first angle plus the other angle, that's 180 degrees. Okay, so let's talk about angles. An angle is determined by rotating a ray or a half line about its endpoint. Okay, so an angle, so remember we've got, this is a ray, and it rotates that little piece, and it can rotate it up or down or whatever, but that is an angle The initial side is the starting position. Of the rotated ray, aka angle. So we could look at that like this. This is the starting position. The initial side is the starting position of the angle. The terminal side is after the rotation of the ray, is the position of the ray after the rotation. Basically, it's the end of the angle right here, which is why we call it the terminal side. And the vertex of an angle is the end point. Let me change my color. Is the end point of the ray used in the formation of the angle. And we know that's right here, where it's the vertex is right there, okay? An angle in standard position is when the angle's vertex is at the origin. Remember that the origin is the point 0, 0, and its initial side coincides with the positive x-axis. So here's what that means. A standard position angle is if this is the x and y axis, right? This is the x, here's the y. We know that the origin happens right here at 0, 0. So it's when the initial side of the angle coincides with the positive x-axis, the vertex is the origin, and the terminal side can be anywhere else. So this is an acute angle in standard position. A positive angle is generated by a counterclockwise rotation. Here's what that means. If we start here, this is our initial side. Counterclockwise from here would go this way. We call that a positive angle, where a negative angle is generated by a clockwise rotation. So if I have this as my origin, here's my initial side, my standard on the x-axis. To go counterclockwise from there, I would show that the angle goes this way, and that's a negative angle. And again, this one is positive, because from standard position it goes counterclockwise, where this one was going clockwise. If two angles are coterminal, they share the same, oops, I'm going to say same and share at the same time, the same initial and terminal sides. Okay, so here's an example of that. If here's my vertex and my initial side, let's say the first one I draw is a positive angle, and let's draw it up here. Okay, so there's my first angle where this is the initial side and this is the terminal side. Okay, here's my angle. I could draw a coterminal angle in the opposite direction with the same initial side, but I'm going to go clockwise instead. Okay, so here we have two angles that are coterminal, meaning they have the same beginning and same end, but they're different angles, right? The blue angle, the positive one, is an acute angle, where the green angle, the negative one, that's not an acute angle, right? That's an obtuse angle, yet they have the same initial and terminal sides. All right, next page. So let's talk about what radian measure is. So hopefully, again, this is not completely new terminology for you, but let's go over it, okay? The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. So again, if I have this is my initial side. Whatever my angle looks like, that's my angle measure. Okay. 1 radian is the measure of the central angle that intercepts an arc, or we call it S, equal to the length of the radius. Okay, so a radian equals an angle that the arc of the angle, which remember, when we have an angle, so let's say here's an angle, okay, the arc of the angle is on the curvature of the angle. So if that's the angle, 1 radian of that angle would be equal to where the arc is as long as this radius here. This is the radius and this is the arc. So algebraically, what does that mean? So how do we write that in numbers? Well, we say that theta, or the angle, okay, this little Greek letter, it looks like a 0 with a line in it, we call that theta, is S over R. So remember, I handwrite it quickly, but 0 like this equals theta. So if you hear me say theta, it just means some unknown angle. It's kind of like when we say x, it's an unknown variable in algebra. When we're dealing with angles, we say an unknown angle could be something like theta. And we know that it's theta equals the length of the arc divided by the radius, where theta is measured in radians. Okay, so now that we're talking about trigonometry, we are going to be using radians a lot more than we used degrees before, like in geometry. A central angle, so remember what a central angle is 1 full revolution, or counterclockwise, and it corresponds to an arc length of S equals 2 pi r. So if it's a central angle and it's 1 full revolution, so here's my initial side, 1 full revolution looks like this, doesn't it? Well, doesn't 2 pi r sound familiar, right? So we know 1 full revolution from start to finish is 2 pi r. Doesn't that sound familiar? Remember that circumference also equals 2 times pi times r. A half revolution, or 1 radian, the radian measure of an angle of 1 full revolution is 2 pi radians. We used to call 1 full circle just 360 degrees, right? Well, we know that 360 degrees, we're now saying, well, that's really 2 pi radians. A half revolution, or half of 2 pi, we would say is pi radians. A quarter revolution, or 1/4 of 2 pi, we would say is pi over 2 radians. And 1/6 revolution corresponds to an angle of 2 pi times 1/6, which is pi over 3 radians. Angles with measures between 0 and pi over 2 are acute angles, and angles with measures between pi over 2 and pi are obtuse. To find an angle that's coterminal, so here's how to find an angle that's coterminal. You're going to add or subtract 2 pi to that value, or multiple circles would be 2 pi times however many times you go around the circle. So we can add 2 pi times n, where n is the number of times around the circle. Okay, so here's what that means. If here's a full revolution of a circle, we know starting here was 0 degrees and we ended at the same spot, but we call that 360 degrees. We know that in radians, if we were to convert it into that measure, 0 degrees is still 0 radians. But 360 degrees is 2 pi radians. And as we cut that circle, we get different measures. So we know half a revolution would end, if this is my initial side, here's my terminal side, half of a circle, which was normally 180 degrees, we now call pi radians. Okay? A quarter of the circle, so starting here and ending at a quarter of it, we would normally call 90 degrees. But in radians, we say that's pi over 2. And we can go even further. A sixth of the revolution, so a sixth of the circle would be like a 60-degree angle, which is the same as pi over 3 radians. And we'll be talking more about that. So how do we find an angle that's coterminal with an angle that's negative pi over 8? Well, we're just going to use our process. You could add or subtract 2 pi. Sometimes the easiest is just to add it. So if I've got negative pi over 8, I'm going to add 2 pi to find something that's coterminal. So to add these, I'm going to need to change this into something with the denominator of 8, which means I'm going to say 2 pi is really 16 pi over 8. So we have that common denominator. And then we have a coterminal angle of 15 pi over 8. If you want a visual of that, here it is. Negative pi over 8 looks about like this. So a coterminal angle of positive 15 over 8 would start here, and we'd go from here to here is 8 pi over 8 because that's pi, and then another 7 pi over 8, and it would end here. So those are coterminal angles. Okay, for example, number 2, it says find the supplement. Remember that the supplement adds to 180 degrees or pi radians, right? So I need to know what will add to pi over 4 and become pi radians. So in order to find that, I can just subtract this from pi. So I'm going to say pi, which is the total of the supplements, minus the first angle will give us the second angle. Well, I know pi can be written as 4 pi over 4 as an equivalent. Subtract the angle, and we get the other supplementary angle. So this is the supplement. An angle of 3 pi over 4 is the supplement of an angle of pi over 4.